section 5.4 exponential function. Let's review our pre-cal a little bit. This is the definition from pre-cal. Ln e to the x is equal to x and e to the ln x equal to x. So let's look at the first example. We want to solve for x. I have e to the ln 2x equal to 12. So I'm going to use this one, this definition. So I'm going to, on the left hand side, I'm going to have this 2x equal to 12. Divide both sides by 2, then I have 6. Let's look at the next example. We want to solve for x again. I have 5,000 divided by 1 plus e to the 2x equal to 2. So what I'm going to do here, I'm going to move everything that have x on one side and the other doesn't have x on the other side. So I divide both sides by 2 and then multiply by 1 plus e to the 2x, then I have this step. 2 go into 5,000 is 2,500, subtract 1, then I have 2,499 equal to e to the 2x. Now I want to bring the x down, so I'm going to take ln both sides because x is on the exponential. So I take ln both sides, the left side and the right side. Now the right hand side, again I apply this definition, ln e to the x equal to x. So I have 2x here. 2x is equal to ln 2,499 divide both sides by 2, then I have x by itself, which is about 3.9118. Alright, so that is pre-cal, so make sure you review this. The next one is calculus, alright. Theorem 5.11, when you take derivative of e to the x, you're going to have e to the x. If you take derivative of e to the u, your u here is an expression, not just a variable. Then you're going to have e to the u and the derivative of u, which is the u dx. Alright, so let's look at our first example. Find derivative. I have y equal to x times e to the x. So I'm going to use product rule. So this is my first term and this is my second term. First term is x, second term is e to the x. I'm going to use the product rule. So you're going to have the derivative is equal to first, which is x, derivative of e to the x is e to the x. First time derivative of the second plus second derivative of the first, derivative of x is just 1. There are two terms here. I'm gonna factor out e to the x, alright? So I have e to the x plus 1. So that's my answer. Oh, I should have one more. Alright, I erase it. So another example. I have y is equal to ln 1 plus e to the x over 1 minus e to the x. Again, I need to have, I want to take derivative of this. So first thing I'm going to do, I have a single form here. The one on the right hand side is a single form. I'm going to write it as expanded form. Alright, so before I take derivative. So this is ln 1 plus e to the x. Division, so you can write as subtract ln 1 minus e to the x. Then I'm going to take derivative from here. This is still my y, so my y prime. And then from here, I'm going to use this definition here from the previous section. If you take derivative of ln of u, you will have u prime, which is derivative of u. So the first term, think of this as u. This whole thing is a u. So I have 1 plus e to the x. Derivative of e to the x is just e to the x. The second term, I'm going to have minus. Think of this as u. So I'm going to have 1 minus e to the x. So the derivative of this will be minus e to the x, which is e to the x over 1 plus e to the x plus e to the x over 1 minus e to the x. You can probably stop here, but I just want to continue a little bit. If you remember, this is difference of square. Let me put difference of square here. If you have a plus b times a minus b is equal to a square minus b square. That's difference of square. So the LCM here, is going to be 1 square, which is 1, minus e to the x square. Think of this as b square. The first term, I'm going to have e to the x times 1 minus e to the x. The second term, I'm going to have e to the x times 1 plus e to the x. Alright, so I'm going to distribute. So I'm going to have e to the x minus e to the x times e to the x is e to the 2x plus e to the x plus e to the 2x. On the bottom, I'm going to have 1 minus e to the 2x. Alright, so I'm going to reduce. This can be reduced. These two terms add to each other. I'm going to have 2e to the x over 1 minus e to the 2x. Alright, that's my answer. See you next time. Hi everyone, let's continue our example. This is theorem 5.12. If you have an integral of e to the x dx, you're gonna have an equal to e to the x plus c. Don't forget the c. And if you have an integral of e to the u du, u here is an expression, so make sure you have derivative of u, which is du here. Then it's gonna equal to e to the u plus c. Our first example here, find an integral of e to the 3x plus 1. So it's look like we can apply the second formula here, which my u is going to be 3x plus 1, right? So I'm going to let my u is equal to 3x plus 1. Then I'm going to take the derivative of this. So my du will be 3 dx. Now look at our original one. I have e to the 3x plus 1 dx. And I want to apply the second formula here, which is e to the u du. And my du is, this is e to the u. My du is 3 dx. I'm missing the 3. I don't have the 3 here. So to make my du, I need the 3. So I'm gonna add 3 to it. So I'm gonna multiply by 3 here. Then I will have my du. If I do that, I have to multiply by 1/3 because 1/3 times 3 is 1. Then I will have 1/3 an integral of e to the u du, which fit the second formula. Then I'm going to have 1/3 e to the u plus c. I'm using the second formula here. And the answer will be 1/3 e. My u is 3x plus 1 plus c. Alright, now let's look at the next example. I have to find an integral of this. So I'm gonna use the formula right here because the first and second formula here doesn't work. So I'm gonna let my u is equal to 1 plus e to the 2x. I'm going to try to apply the formula here. My du would be e to the 2x. Now the derivative of 2x is 2 dx. Alright, let's look at our original one. Our original one, I have e to the 2x over 1 plus e to the 2x dx. That's the equation that we have. So I'm trying to fit this formula. So I have my u, my du should be this one. So I'm missing the 2. I'm missing the 2 here. If I have 2, I have du. So what I'm going to do, I'm going to multiply by 2. And then I have to multiply by 1/2. Then I have a 1/2 and integral. This is just du. And this is u, which is with our formula. Then it's going to equal to 1/2 ln absolute of u plus c. This one right here. Now I'm going to substitute my u back, which is 1/2 ln absolute value of 1 plus e to the 2x plus c. Alright, that's the u substitution. So let's look at the last two examples. I have an integral of this. I'm gonna let my u be negative e to the x, negative x squared. My u is equal to negative x squared. And if I take derivative of this, I will have negative 2x dx. I'm planning to use this formula right here, the second one. Alright, so I'm gonna use, just to write a note here, e to the du is equal to e to the u plus c. I'm gonna use this one. Alright, so from the original one, I have e to the u. My du should be negative 2x dx. I have x dx already, so I need negative 2. What happened? I bring the phi out. So I have e to the u du. Just fit that perfectly. And then I have 5 over negative 2. Because I have negative 2 here, I have to have negative 2 here. And I apply that theorem there. So I end up with negative 5 over 2 and integral of e to the u du, which is e to the u plus c. And the negative 5 over 2 is from the front. And I substitute the u back in, which is negative x squared. That's my answer. Alright, so let's look at the last one. I need to find an integral of ln e to the 2x minus 1 dx. If you remember the earlier section, ln e to the x equal to x. Now if I have ln e to the 2x minus 1, this will equal to 2x minus 1. So I just take an integral of 2x minus 1 dx. I have 2x squared over 2, which cancel out with x squared. Negative 1 integral of negative 1 is just negative x here plus c. Alright, we finished 5.4. Bye.